Now let's focus on some common names of aldehydes and ketones that you need to know, in addition to obviously the IUPAC naming system. A one-carbon aldehyde is called formaldehyde. So one carbon is formaldehyde. Two carbon aldehyde is acetaldehyde. You're going to see acet used in another chapter where acetic acid is a two-carbon acid. You'll see the form used also in the acid chapter. Formic acid is a one-carbon acid. So formaldehyde, one carbon. So IUPAC, this would be methanal. IUPAC, this would be ethanal. Three carbon is propionaldehyde. Four carbon is butyraldehyde. And that's enough for common names of aldehydes. So if you know these four, you may see valeraldehyde. I don't think so, though. I think mainly the homework questions deal with these four. If by chance on the homework you see any of the ones that I haven't covered, not a problem. You can read the chapter. You should be able to answer anything if you've got the book there, so you can always read. All right, so these are the common names of aldehydes that I want you to know. The common names for ketones, remember the smallest ketone is this guy. It's got 3 carbons. This is propanone. That would be the IUPAC name. Now, if you're going to use a common name, you name it sort of like ethers. Remember how with ethers you put the O in the middle and then you name the 2 alkyl groups on both sides? So you name this alkyl group and this alkyl group. Well, this one is a methyl group, and then this one is also a methyl group. So you call it dimethyl ketone. So if you had an ethyl group on this side, ethyl group on this side, it would be diethyl ketone. If you had a methyl on one side and an ethyl on the other, it would be ethyl methyl ketone. So it's named, the common names are similar to the common names of ethers, but now you just put the word ketone at the end. This one also, this specific one is also called acetone, you know, nail polish remover. Propanone is the IUPAC name, but these are 2 common names for this one, either acetone or dimethyl ketone. All right, like I mentioned earlier, ketones and aldehydes are actually isomers of each other. Let's prove it. Here is a 3-carbon aldehyde. And then here is a 3-carbon ketone. If we count the number of carbons and the number of hydrogens, it's C3H6O. Can everybody see that? 1, 2, 3, 4, 5, 6, and an O. So an aldehyde, this is propanal, this is propanone. Here you don't have to tell me that the double bonded carbon to oxygen is at carbon 2, because it can be nowhere else. It's got to be at carbon 2. It can't be here and it can't be here. Ketones are never going to be at the ends. They'll always be in the middle of the molecule, just like ethers. Okay, so aldehydes and ketones are isomers of each other. If you have a ketone, you could have several different isomers of a ketone. Just move the carbonyl group. So I could have a carbonyl here, and this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be 2 nonanone, and then you could move it here. That's 3 nonanone. And you can move it here. It'd be 4 nonanone. Over here, it would be 5 nonanone, and then over here it's the same as the other way. So you could have 2 nonanone, 3 nonanone, 4 nonanone, and 5 nonanone. And then you could maybe make it like this, put in an ethyl group. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have this, and then you could have a carbonyl here. So this would be an isomer of this. You can play around with it quite a bit. So not just changing the structure, but changing the location of the carbonyl gives you a new isomer. Okay, so that's it for isomers of ketones and aldehydes. And we are ready, according to the what you need to know list, to move on to physical properties. Remember, physical properties are all about solubility and boiling point. So let's first focus on solubility. Now, if you've got an aldehyde, like this one, for example, this is ethanal or acetaldehyde. Okay. And you have a molecule of water. You can have some hydrogen bonding right here. Because of this lone pair here, you can have some hydrogen bonding. In general, aldehydes and ketones are more soluble in water than alkanes, but way less soluble than alcohols, okay? And phenols, remember, phenols are big and bulky. They're not that soluble in water. That was from the previous chapter. Even though they have that slight charge to them, that big bulk of the molecule doesn't really make them very soluble. But aldehydes, if it's a short molecule, there's a little solubility in water. Just when you're ranking it, it's going to be less soluble than alcohols, but more soluble than alkanes because of this lone pair. All right. Now, what about boiling point? And the same thing holds true for ketones. What about boiling point? With boiling point, it's all about the intermolecular forces. So just imagine, I shouldn't have erased it. There we go. Let's say I have this aldehyde again. And the same holds true for ketones. So I have this aldehyde, and then here's another aldehyde. Same one. So ethanal and ethanal. Will they do any intermolecular hydrogen bonding? Do you see a hydrogen attached to an oxygen? No. You see a whole bunch of other hydrogens, but they're useless hydrogens. They can't do any hydrogen bonding. So since these guys cannot do any intermolecular hydrogen bonding, their boiling point is obviously going to be a lot lower than alcohols. What they can do is a little bit of dipole-dipole because this carbonyl gives you a little polarity. And they can obviously do London forces. So if I have these molecules, let's say I have one propanol, and I have propane, and I have propanal, okay, and then maybe I have, let's say, ethanal. All right, so I have, this is 1, 2, 3, 4. And I ask you, all right, rank them. Who's going to have the highest boiling point? The one that has the most intermolecular forces is going to have the highest boiling point. So you look at them. 1-propanol, this is an alcohol, so it can do hydrogen bond, it can do dipole-dipole, and it can do London force. Propane, alkane, super boring, doesn't have any polarity. The only thing it can do is London force. Propanal and ethanal, they're both aldehydes. They can't do any intermolecular hydrogen bonding, but they can do dipole-dipole and London force. Okay, good. Now, obviously, this one's going to have the highest boiling point because it's got the most intermolecular forces. So this is going to have the highest boiling point. And hopefully you can see, obviously, that this is going to have the lowest boiling point because it's got the least intermolecular forces. So this is the lowest boiling point, and this is the highest boiling point. Okay, what about these two guys? They have the exact same intermolecular forces. But remember from our last couple of videos here, we said that London forces are greatly affected by the length of the chain. So since propanal is 3 carbons, ethanal is 2 carbons, these London forces are stronger than these. So if we're going to rank them, 1 would have a higher boiling point than 3, which would have a higher boiling point than 4, which would have a higher boiling point than 2. Okay? All right, next video we're going to deal with the chemical properties.